Okay, so we're going to discuss and think about the double slit experiment. And what we're going to do is we're going to analyze what happens, what would happen or what happens in the case of particles going through a double slit experiment, and analyze the case for the case of waves, and see how they differ. And then we're going to analyze what happens with quantum particles such as photons or electrons. Okay, so here's a schematic of a double slit experiment, and this graphic and several of the graphics in the next few view graphs are actually taken directly from the Feynman lectures in physics, a very classic and beautiful 3-volume set which any serious physicist should acquire. And this happens to be from volume 3. And so Richard Feynman envisions this experiment where you have it's a double slit experiment. You have a wall that has 2 holes in the wall, or 2 slits, and you have some machine gun shooting actual bullets through that wall. And you imagine it so that the wall is indestructible, so that the bullets hitting the wall will just bounce off. If they go through the slit, they'll either pass straight through, or if they happen to catch the edge of the slit, they might reflect, as shown here. Okay, and then over here we have some backstop, which is going to stop the bullets. And we also have on that backstop, we have some sort of detector, okay, which we can move around up or down, okay, and basically count. So every time that a bullet hits the detector, it will just register that, it will count it. And so over time, as we hold this, we shoot a bunch of bullets and we hold this this detector still or for a little bit, and we can basically count the number of bullets that arrive at a particular value of x, where you can't probably see it very well, but x is just the distance from the center of this line of symmetry up or down along the backstop. And you can just count the number of bullets that arrive at that position and divide that by the total number that are hitting the backstop. Or, if you like, if we arrange it so that the machine gun is firing off a certain number of bullets per unit time, and we're just counting here per unit time, then we can take the ratio of that. And so the probability at any particular position of the detector is just going to be the ratio of the number of bullets that it detects at that position to the total number that are arriving at the backstop, and again, which is proportional to the ratio of the rate of bullets that you detect to the rate of bullets that the gun shoots. Okay. So what happens if we look at the distribution of bullets as a function of x when we just open one slit? So imagine that we close slit number 2 here. Okay, we close slit number 2. Then what we would, so that bullets can only go through slit number 1, and then what we'd find is this distribution over here, P1. Okay, we would find that the bullets basically peak around a position such that the bullets go straight through. Okay, so this position here is the maximum, because that's where the bullets just sail straight through and they don't get knocked around or reflected off the edges or anything like that. But of course, some of them are going to bounce a little bit up, some of them are going to bounce a little bit down, and so you have this sort of broad distribution. And if you did the same thing by opening up slit 2 and covering up slit 1, okay, then you'd get just the opposite effect. You'd have the same distribution essentially, but it's centered down here. Now, the question is, what happens when we open up both slits? Okay, so if we open up both slits, then we get a distribution that just basically looks like this. It's instead of you basically just add the 2 probability distributions, P1 and P2, that correspond to the individual slits being open, and when you do that, you get a curve that looks like this. It has a peak in the middle and drops down, and the exact shape of this depends on how far apart the slits are and some other factors, but for this geometry, this is what you'd get, something like this. And so for particles, that is in this case bullets, we find that the probability of finding a bullet at a particular position x is just the sum of the 2 probabilities that correspond to this one slit being closed.